These are the very base. Let me start out with a very basic graph. R equals 5. What's that telling you? Any angle you go to, the R value is 5. Remember, that tells me how far I go out from the middle. So you want to start at 0? All right, you go 5 away. 1, 2, 3, 4, 5. There's your point. Pick another angle. Pi over 6. It's still 5. Everywhere you go on this graph is 5 units. No matter what the angle is, it's 5 units. So you start plotting all the points that are 5 units away, no matter what angle you're at. What's it going to start forming here?
A circle.
It should start forming a circle. So when it's R equals just a single number, you should have a graph of a circle. So does everybody see how that works? With R equals just a number, any angle you go to, you should be going 5 away from the center. You're ready to check it now. Let me show you how your calculator works with these now. Because I would prefer that after you were done with the graph, you want to make sure it looks like what it should look like. All right, so you go to your graph. We go to Grapher because that's where we graph everything. And now it says R equals 5, right? R equals 5. All right, so we got to type in R. And R is located above the number 4, the 4, but on the 4. So you have to go alpha 4. And then R will pop up. I'm not showing you this tomorrow, so practice it now or never.
Can you do any variable?
No, it's got to be R because that's what's on your paper. All right, that's how the coordinates work. Equals, what was it, 5? R equals 5, enter. And look what it comes up to be. It's already going to tell you it's going to be a polar equation of the circle. You can go ahead, plot the graph, and there you go.
Wait, what do you?
Okay. So it should show you it's a circle. Now, if you don't like, because hey, you see where it graphed it on your old XY grid. If you want to get a polar graph up to be 100% sure, you head up to axes. All right, head up to axes, enter, and then you see how it says grid type. Right now we're in old school, what's called XY Cartesian. And then if you enter, you can say, hey, actually, let me see it in a polar graph. Confirm. And then you'll see it in the polar form. Okay? Just to make sure it matches up with yours. All good. All right, let me move on to the next one. Y or R equals -3. Well, what did the negative always tell us? Go away, right, on the other side. So if I'm at 0, what this is telling me is go 3 in the other direction. But guys, let's be honest here. What's still going to happen? Still going to be it doesn't matter where I go. Okay, you want me to go opposite? Sure. I'll go opposite, but I'm still going to be 3 away every time. Killing me.
I'll just throw it out at him. You still got to drink the milk. Makes him hungry.
We all good on just a single number? Because now they're going to get more complicated, which requires more effort on your part. I know. Any questions on just R equals any number? All right, you ready for the? Are we all ready for the next one? Draw your circle in here, 3 units away, and let's roll. So tough to draw that circle in, I know. All right, now I'm going to start adding sines and cosines now. Okay, so we require a table to fill in so I can graph these points. First thing, before we do anything, can you notice the table, please, that I'm going to have you fill out? All these angles are in what? Radians. So guess what? We got to go to settings. Make sure to tell our calculator we're about to plug in radians. So go to settings, And make sure it's in radian mode, please, because it won't work if it's not. Everybody in radian mode. You'll notice there are a lot more. I set up the graph for you here, but I only want you to fill out these here. I don't want you to fill out any other points. All right. So let me show you how you fill out the table. It's like any other graphing table. You're going to start with zero radians. You're going to plug it in, 4 cosine 0. So everyone go to your calculator now. Go to calculations. 4. Make sure you're in radian mode. Me too. Not doing this for you tomorrow again. 4 cosine 0. What do we end up with? 4. So your R value in this case is 4. So the point you're going to graph is 4 comma 0 degree or radians in this case. Me personally, I like to graph it after I fill in the table. If you guys want to do it one by one, I don't know. What do we want to do as a group? I don't want you to have to follow my lead. Do we want to graph it after we find it? Or fill out the table and graph it?
Should fill out the table first.
Okay, let's fill out the table then. Now you're going to do 4 cosine pi over 6. 4 cosine pi over 6. All right, I probably just put like 3.5. Right, you don't need to write out the whole thing. 3.5, so you're in the ballpark. So that's going to be 3.5 comma pi over 6. I don't think I need to keep holding your hand here now. Go ahead and fill in the table, and then we'll graph it together. Make sure these numbers can come out of your calculator, not just copying it off the board. Okay, looks like everyone's got it filled out here pretty much. All right, you ready to graph it? And again, this is, hopefully this is not a struggle for a few of you because you still don't know how to graph yet. 4, 0. You go to 0, go 4 out, right? That's what 4, 0 means. Go to 0 radians, 0 degrees, go 4 out. 1, 2, 3, 4. Now we go 3.5 pi over 6. And the best part is I've labeled the darn thing for you. All right, so you just go to pi over 6. It's already labeled there for you. 3.5 out. 1, 2, 3.5. Please keep in mind how you're plotting them because that's how we have to connect them. We got to connect them in the same order we plot them. Okay, there's a little connect the dots here at the end. 2 pi over 3. Zero. All right, let's talk here. 0 pi over 2.
Middle.
It's going to be the pole. All right, we're going to graph at right here at the pole. There's my next one. Now you got to be careful and lock in here. At 2 pi over 3, we have a -2. Hey, look at mine. No. What's negative tell you? Go to the opposite side, directly opposite, right? You got to pay it. If the R value is negative, you got to go directly opposite. Oh, cripe, I should have handed out rulers, huh? Are you guys good? I think we can handle it. Me too. Right there. That's where I end up. And then keep going. 5 pi over 6, -3.5. So you go to 5 pi over 6. Negative tells me go directly on the opposite side, 3.5. And then something starts happening, kids. Everyone at -4 and pi? I'm at this point right now, -4 pi. What happens? Here's pi. -4 tells me to go this way. What happened? Same point I originally graphed. Okay. -3.5, 7 pi over 6. What do you notice? Same point again. I'm starting to repeat now. 0, already graphed it. And then 2, 5 pi over 3. 2, 5 pi. Where's 5 pi over 3? Right here. 2, up, already graphed it. And then, yes, some of you guys are figuring out already.
Circle.
It's a circle. Yep, right. If you want to confirm it, graph it. Okay, if you want to confirm it, graph it. Questions on that one? And I will show you after we do this next one, I'll show you how you can look at it and already know before we graph it what's it going to be. All right, here we go. 6 sine theta. Go ahead, run through your table for me. All it is type the numbers into your calculator. 6 sine of all these right here. I'm not going to put mine up to the end so we don't have any onlookers. That's fine. Yeah, I'm not looking for exactness anyway. I went 5.2, but 5's fine enough. 5's all right. It'll get the job done. All right, all good. Check the tables. Ready to graph it. And then I'll show you a little secret about how you can already tell what it's going to be before we do anything. All right, 0, 0, 3 out to pi over 6. Went too far. 5.2, 5. 6. 2 pi over 3. Back to 0. And I believe we start repeating after that, right? Use your calculator to make sure this is what shape it should be here. All right, this isn't one of these bad boys. Okay, take a look on your calculator. The reason why it looks like that is because I'm not having you do anything in between to make it look more detail. All right, so that's why I want you to use your calculator to say, hey, it's not supposed to look like that. I'm not going to give you credit for that either. All right, we should have a circle going here. So please check your calculator before you bring it up to me tomorrow to make sure it does match what it should look like. All right, final thing here before I move on, because we are going to go on to a different figure. Anytime it's just a number with sine or a number with cosine, that's a circle, kids. That's a circle. And you can tell where it is. Sine, always on the y-axis. All right, cosine, see where it ended up? On the x-axis. And you can always tell how far it goes out. Like this one here went out to 4. How do you think I could tell that at the beginning? The number out in front. Hey, real quick, what if I do this on you? -5 without graphing. What do you think it's going to look like? It's going to be on the y-axis, but instead of up here, it'll be down here going to 5. All right, so you can tell what it's going to be before we even graph. Good on the circles, because now we're going to up it now. Now we're going to get real artistic. Not a circle, right? Because I added that extra 5 in there with subtracting. Okay, fill in your table. Still, fill in your table. We got to take our time graphing this bad boy. Bless you. I should have mentioned that before. Use a rounded answer too if you want. Just make sure we got the right one here. Before we graph them here together, take your time. All right, let's see how we do graphing these points. 5 out to 0. 2.5. Oh, a tiny one there at pi over 3, huh? Don't even go a full one. Then we come to 0. Another tiny one, barely one. Just pay attention to the degrees because I skip over some on this grid here. Before you graph it in, figure out what it looks like. I should have went over this before. This is my bad. For the theta, you can just press X and your calculator will know it's theta because you used R with it already. All right, so that's nice. Your calculator's smart. All right, so I typed in 5 minus 5 sine. I used the X button and it popped in theta for me because I want to get an idea of what this looks like before I graph it. And then take a look there, kids.
Hard.
Yep, something which I do not possess. Yep. That's what it should look like.
Every day.
Okay, whoa. Okay, everyone good? What it should look like? All right, this has an official, we'll call it the heart, obviously, but it's got an official name. Cardioid graph. Cardioid. And how can you tell it's going to be a cardioid? Same numbers there.
It's not plus or minus. It's just
The plus or minus doesn't matter. You could put a plus in there. You could put a minus. The minus, the plus would tell me it's going to shift up. Okay, but it's got to be the same numbers for it to be a heart. Okay, got to be the same numbers. All right. Any questions? I got one more here for you, and then we're done for the day. All right, what happens if I change the numbers? Okay, they're different numbers now. It's not going to be a cardioid anymore. It's got a different name. Watch this bad boy. Woo! You thought plotting points was important before. This is huge. So fill out your table. Any predictions what axis I'm going to be hanging on here?
The X.
Yeah, I'm going to be on the X. What do you think, the positive or the negative side?
Positive.
Yeah, it's going to be probably something over here, I bet. Just based on cosine and being positive. It's not going to be a heart, though. No heart on this one since the numbers don't match.
It's a squiggle. Interesting.
this one together because gets a little creative here. All right, we ready to roll here, huh? Follow the order you plot them in. Don't forget about the order here because you're going to have some overlap that you got to go past. 5-0. Remember the order you plot them in. Okay, you're going to deal with negatives now. Got to go in the other direction, please. Other direction. 2 pi over 3. You got to go in the other direction.
It's there. That's not even. Okay, a lot of dots. You follow the order. And just to be on the safe side, we got 1. The circle within the circle, the loop-de-loop. If we follow the order of our points, that's where it should end up here. Not interested in what that's called, huh? That is called a
Loop to
double.
loop. Double loops.
Cardioid when the numbers matched, when they don't. I gotta make sure I spell this correctly. Lima-san.
Yeah.
I'll put this back for you when you don't eat a chicken wrap.
Does it taste good?
Tastes good.
It's good.
I don't know what's good.
I didn't smell back here.
I thought that was a joke from Will. It's that bad.
Yo.
Limit time.
Oh, yeah.
This guy is creepy as some of you.
Yo, Max.
He's not creepy, he's just French.